Welcome back to another lecture in our series on development and applications of special concretes. Having started this week with a lecture on curing, continuing with that with cold weather and then hot weather, I'd like to close this week with a special discussion on the importance of having the right methods and specifications that actually suit the method of construction. Now, as far as the right specifications and the right methods are concerned, they start with normal concretes and have to be adapted, or new methods and specifications have to be given for special concretes. Now let me start the discussion by just reiterating that the concrete construction process consists of batching, mixing, transportation, placing, compaction, and curing, and there are different processes involved. All these processes have certain ranges, and within that range, concrete can be called normal, or the concreting operation is normal. And if one of these processes goes out of that normal range, the others have to be adjusted accordingly, and then the whole thing has to be treated as a special process. So the discussion today would be largely in terms of how geared our normal specifications and methods are in treating or for treating special construction conditions of concrete structures. Now this is a reflection of what we do as far as normal concrete construction is concerned. We take concrete in the lab, so this is of course in the lab because that's where the whole process starts. We start the process by having a proportioning exercise carried out in the lab. So how is the proportioning exercise carried out? We've already gone through the proportioning part of it. We have some concrete, we mix it with a certain proportion, we carry out the slump test, the way it's shown here. Then we fill out these cubes. Cubes we fill in India, in other countries you may fill some other specimens, maybe cylinders. We have them in 2 layers or 3 layers, whichever is prescribed in the code. Tamp them the way it is shown here, get to this form, get to this form, finally get cubes here, demold them, cure them, and test them. So this reiterates to you or helps you recall the normal process where concrete proportioning is done, the mix is determined, and the concrete is said that okay, this is the mix that we will use for carrying out a normal construction. Now, this is a summary of that. We carry out trial batches in the lab. We may carry out additional trial batches in the site laboratory, and we determine the proportions for use as far as the site is concerned or as far as a particular project is concerned. And as far as these trials are concerned, we take care of the fresh properties and hardened properties, that is properties of concrete in the fresh state and in the hardened state, whether it's in the form of slump or it's in the form of compressive strength, flexural strength, or whatever it is. Please remember that while we are trying to carry out these laboratory tests, when it comes to properties of hardened concrete, it might take time. So one has to be a little careful when we are trying to do adjustments for strength, because this could take about 28 days, 56 days, 7 days, whatever it may take to be able to decide a mix. Whereas fresh properties, the adjustments is reasonably quick because we can say that okay, if we have one batch, do the slump. If it doesn't work, do another batch, do another slump, and so on and so forth. So keep this in mind. Remember that as far as the quality control is concerned, we had talked about something that if in the project the allowance given to me in the slump is plus minus 2 centimeters, then in determining the mix as far as the laboratories are concerned, we try to have a window which is only plus minus 1 centimeter. Similarly for air, if I have a window of plus minus 1%, I try to use only plus minus 0.5% kind of a window in the lab. This is my project window for air, and I use a narrower band, have a stricter quality control in the lab environment, because only then we are trying to buy an insurance against some variation that will arise out of the changes in the material properties being used at site and so on. Now, this is an example from IS 516, which gives you in great detail what kind of a tamping var should be used, how should the compaction be carried out, if it is being carried out by hand, if it is being carried out by a vibrator, how should the specimens be capped. So there are a huge amount of details given here, 35 strokes per layer for 15 centimeters and 25 strokes per layer for 10 centimeter cubes. So these are the kind of details which are laid down as far as preparation of the specimen is concerned for normal conditions. One thing you should remember always, that the concrete that we are trying to test, the concrete proportions that we are trying to determine, and finally the concrete that we test for strength or slump or whatever it is, the idea is that the concrete should be suitable and it should serve the purpose in a given structure. So all these cubes that we take are of course not a true representation of the strength that will develop in concrete in an actual structure. So that is something which is known to us, and that's why we say that this is the cube that is being used for quality control of concrete. Now, if somebody wants to know exactly what is the strength of the concrete in a beam that has been cast, the answer is that these cubes are only a reflection of that strength. They are not the true strength of that concrete, because the curing conditions are different, the placing conditions are different, the compaction conditions are different, and therefore in the strict sense a quality control engineer or a concrete engineer can never say that these cubes truly represent the strength of the concrete as developed. This is something which is known in the profession, and within that knowledge, within that limitation, or within the limitation of that knowledge, we carry out our design, we carry out our construction, and we are doing reasonably all right as far as we are concerned. Now, having said that, where the specification was very clear about the tamping rod and the kind of tamping that should be done and so on, there are places where the specifications may not be very complete. Here is an example of that. IS 456 at some place says the concrete shall be placed and compacted before initial set of concrete commences and should not be subsequently disturbed. Now, here the specification clearly says, or the document clearly says, that we are talking about the initial setting time of concrete and not of cement. Of course, it is clear that cement is the only reactive material in component, the reactive component, and there will be a relation between the setting time of cement and the setting time of concrete. But please keep in mind that the setting time, whether it is the initial setting time or the final setting time of cement, is a quality control parameter of the cement. It has nothing to do with the actual setting time of concrete, because the mixed proportions are different. You're not using the same quantity of cement everywhere. The placing conditions are different. The temperatures at which you're placing the concrete is different, and therefore it stands to reason that the setting time of concrete should be independently determined. We've talked about how initial setting time of concrete can be determined, but that should have been reflected in the specification. If it had been added that the initial setting time of concrete as determined by such and such, then it becomes so much easier. There's no mention of how the initial setting time of concrete is to be determined as far as the specification here is concerned. So can the setting time of concrete be taken as the same as that of cement? I've already given you the answer. The answer is clearly no. Another example, again from IS 456, it clearly says that where freezing and thawing actions under wet conditions exist, enhanced durability can be obtained by using suitable air entraining admixtures. When concrete lower than M50 is being used under these conditions, the mean total air by volume of the fresh concrete at the time of delivery into construction should be given here. So if the maximum aggregate size is 20, it's 5 plus minus 1. If it's 40, it's 4 plus minus 1. It also says that since air entrainment reduces the strength, suitable adjustment may be made in the mix design to achieve the required strength. So once we are writing this kind of document, certain things are clear. It says that for less than M50 grade concrete, because M50 is possibly a limit which the code is telling you, that beyond that, please don't rely on this document, try to do your own research. As far as this document is concerned, it's up to M50. At the time of delivery into construction, that means it's not talking of the concrete properties at the ready mix concrete plant. It's talking of certain air percentages, but it does not make the air measurement mandatory. See, unless you have air measurement and its method mandatory, and especially in this day and age where air entraining admixtures can be used for other purposes or other conditions than, let's say, freezing and thawing, it's very difficult to control the properties of concrete. So certain undesirable things may happen. So there is no mention of measuring air in fresh concrete. The test method involved, of course, it's a very simple apparatus. We all know that. We've talked about it in the previous discussions when we're talking about mixed proportions. So the idea basically is that the specifications have been written for normal constructions. When it comes to special constructions, the onus shifts a lot to the clients, to the contractors, to the users, regulators, everyone, to develop new specifications, to kind of come up with more appropriate test methods, more appropriate specifications, more appropriate kind of proportions and sampling procedures possibly, which ensure that the concrete that you collect, the concrete you test, is actually representative of the concrete that is cast. So the discussion today would be in terms of large projects where the proportioning of concrete is one of the first steps. And once the proportion of the concrete, that is the different ingredients, established, a lot of other things have to be done. Now this exercise, as far as the proportioning of concrete is concerned, should be carried out obviously keeping in mind the material to be used, the condition and the method of construction. I'm going to highlight this part when it comes to some of the examples that I'm going to take up today. The sampling procedures need to be formulated, reformulated and brought in line with the conditions and the method of construction. So the sampling procedures have also to fall in line with the conditions and methods of construction, as I will explain to you with some examples. There are guidelines and specifications available which can be used as reference, but we need to review them. My advice to you is always have healthy disrespect for any specification, including test methods. It should be healthy because there is a lot of wisdom in each line that is given there. It helps you standardize the process. It helps you make it more robust. But we have to have a little amount of disrespect with it because they are not etched in stone and should be changed in case of need. See, for example, even for ISO 456, if we feel that yes, there is a need to change it, the engineers should be free to change it for a particular project. And that freedom is always available to you in the documents. In the contract documents, it does give you the freedom that, okay, IS 456 is mandatory, but anything over and above that is always welcome. And once that becomes the norm, it will be practiced in more and more sites. Of course, there are clients, consultants, and contractors involved in a project, and each of them has a different role to play. Somebody can say that I'm only a contractor and this is the specification told to me. Now, we are not talking in this set of lectures of a scenario where we have this kind of a closed mindset. We are talking of an environment where true professionalism is working, and it's only a matter of time that the true professionalism will come in and has come in a certain way, where we say that this method is not applicable here and therefore let's try to do this method which is more applicable. If the specifications are good and complete, a greater chance of better quality construction. So whether it is proportioning of concrete mixes, whether it is testing and sampling of concrete, the procedures involved therein, if sufficient amount of homework has been done in order to lay down the right kind of methods, the right kind of sampling procedures, the right kind of planning has gone into the project, special concretes and the special projects are more likely to succeed. If we jump into those projects, start those projects with inadequate preparation, it is more likely to run into trouble than otherwise. In sampling and testing and interpretation of test results, keep in mind the conditions of sampling, method of sampling, curing conditions, how should the cubes be compacted. I mean, these are the kind of things which are very, very mundane, which are very, very obvious. Somebody will say, what is the big deal about it? But if you see the site, if you think about it, there will be a specification which tells you to tamp the cubes or vibrate the cubes. In certain cases, it's not possible to do that. Then how should the cubes be taken? Somebody has to think about it. Somebody has to come up with a procedure so that it can be still robust as far as that particular project is concerned. Simple questions like sampling for slump or air content should be at the RMC plant or at the site. As far as 456 is concerned, for air it was very clear that it should be at the site of construction. Similarly, you can have a specification that even at the plant it should be such and such. Because at the end of it, there is a lot of funding. At the end of it, there's a lot of money involved. All these decisions at site involve rejection of concrete, reconstruction of the structure, and that's an extremely expensive affair. It must be avoided, and it can be avoided only if we have good specifications. We have as many checks and balances as possible in our construction procedures. The structure is not likely to be cured under immersed in water conditions, and therefore we understand that. So this part we clearly understand and we know how to handle it. But there are so many other things, as we will see in the discussion today, that need to be accounted for in our sampling process. Bottom line, never forget this. The sample should represent the real concrete. We understand that it will never be the real concrete. It has never been. All this business of testing cubes and cylinders, curing them underwater to get 28 days strength, does not reflect in any way or form the actual strength of concrete in structures. But that's something which we know about and we have learned to live with it. The issue is that as we are trying to get into more and more special constructions or special kinds of admixtures and concretes, we need to be aware of more issues. Once again, this is just a reiteration that if some of these things change, a lot of the others, in fact, most of the others will need to be appropriately adjusted. Here is an example. Now we'll take 3 examples today. Here is an example of PQC being unloaded at site. PQC is pavement quality concrete. Now, concrete is being brought to the site using this kind of a dumper and is being unloaded the way it is shown. Now, from here you can probably get an idea that, okay, is this the way we had foreseen the concrete will be placed when we tried to do the mix design in the lab? What is the kind of workability that we have and how was the workability measured in the lab and so on. This is the way PQC is being spread at site. Is this the thing which we had thought will be done in the laboratory tests to determine the mixed proportions? Sticking with PQC, this is the start of paving using an automatic paving machine, a paver. This is the paver machine, backside of it when it is not operational. This is how the concrete is being vibrated using the vibrators in the paving machine itself. So there is this large panel of vibrators, and as the paver moves, the concrete is vibrated along with the movement. This is how it is being finished using a trolley on which you can see the masons doing the finishing works. This is another operation which is very typical of pavement construction, which is texturing and curing. Curing, of course, we know, but texturing is something which we try to do on the surface of PQC to impart the right kind of friction so that we have a good grip as far as the tires are concerned and so on. That's something which you know from your rigid pavement design and rigid pavement analysis. This is texturing and spraying of curing compound being carried out. Now the question, for example, would be that how do we do the texturing as far as the laboratory is concerned? Somebody asks, at what time should I do the texturing? Should I do it immediately after placing? Should I do it after 30 minutes? Because that's something which the site people or the person who's operating the paving machine would like to know. In order to be able to give that answer, somebody has to try a couple of things. I'm leaving it to you to think as to what are the things that are required to be tried out for that. But we have to do some experiments. Now, is a cube kind of a sample good enough to do texturing? It can be understood that yes, texturing in the laboratory will be at a different scale. But think about it. Will that represent the real concrete that we have placed? And what is the solution? We'll talk about it briefly towards the end of this discussion. Just think about it. Here is another example where we are trying to do underwater concreting using a Treme. What happens there is something like this, that we have a deep structure where we are trying to place this concrete mass using a Treme. So we'll talk about this Treme construction a little bit later, but today the discussion is focused on only to highlight that this construction is not something which we had bargained for when we tried to do the normal mixed design. So when we are trying to do the Treme kind of mixed design, we can say that, okay, as far as the flowability is concerned, as far as the workability is concerned, this is what we want because this is how we want to place the concrete. That's all right. But this concrete, the fact that it will fall through so much, the fact that the concrete will be here, and this is the concrete which needs to be represented as far as my fresh concrete is concerned and the hardened concrete is concerned. How should we sample this concrete? How should we carry out the tests for workability? Is there something special that you need to do? Here is a live photograph of that, where you have a Treme pipe here. This is a schematic sketch. This is the photograph. So there's a Treme pipe, there's a steel gauge. You're trying to put the concrete being placed here. And that's what you're trying to do here through your agitator truck. You're trying to dump the concrete into this hopper kind of thing here, and it is going down. Coming to a third example of special conditions of construction. This is a tunnel shotcreting. So this is a shotcrete kind of an operation where concrete is being gunned onto the surface. The same thing is being done here. Concrete is being gunned or placed under pressure against a surface. So there is no real form work involved. There is no real curing which is possible as far as underwater curing is concerned. We might try to have curing compounds, we might try to keep it wet through a hessian cloth and so on. But is this the kind of concrete that we had in mind when we did the mixed proportioning in the lab? In the lab, when we placed the concrete, how did we place it? In the lab, how did we determine the strength of this concrete? This concrete here has been placed, not the way it was placed in the lab, but it has been gunned onto a surface. And if we try to do the regular cubes, does it really represent this construction condition? The answer clearly is no. So then what should be done? We will have another couple of photographs about shotcreting, and there are a couple of things which you would learn. Here is another kind of shotcreting going on, where the shotcreting is on the top. That means the shotcreting will happen from the bottom, which means there will be a lot of rebound. So these are things which we can discuss during the shotcreting methods and the shotcreting proportioning of shotcrete, because we need to have a certain type of property and so on, which is fine. But The issue today is how do we develop the right kind of specification to be able to ensure that the strength at some place here and the strength at some place here is all in order. The designer expects that the strength, if it was a tunnel like this, the strength of the concrete here and the strength of the concrete here is both a certain number. It may be the same, it may be different, those are design conditions, but as far as the concrete is concerned, how did we place it? We placed it quite differently here than here. How was this factor incorporated, if at all it was incorporated, in our laboratory studies, which were used to determine the mixed proportions? Similarly, another application of shotcreting is in slope protection. So you're trying to concrete a slope. You're trying to deposit some concrete on the slope, which could be using some amount of reinforcement kind of a material here, which is placed like a net. You could see some of those nets even in the tunneling operations. Here we can see that clearly. We can see this reinforcement which has been placed, and we are trying to place this concrete here against the slope. No form works, and we are expecting that as far as shotcrete is concerned, this is the reinforcement that we have placed, and let us say it is placed somewhere here, and this is my surface. So if we are gunning it here, the concrete is expected to reach all these places at the back and have a deposit which will become something like this with reinforcement bars somewhere here. So how is this construction condition taken care of when we are trying to do the sampling at the lab, when we are trying to determine the kind of concrete that we will use? The same thing is happening here, just another example which shows the reinforcement and the concrete being deposited. Same thing with more difficult conditions as far as placement are concerned, because the people who are depositing this concrete are now on a platform at an elevated location. You may have certain positions in which the concrete has to be placed. You have to bend in order to deposit the concrete here. You will have to bend to deposit the concrete in the bottom of the tunnels or the bottom portion. So now, if we go back to this slide, I suppose you have a better idea of what was being talked about. That the proportions of concrete is the first step, and this exercise has to be carried out keeping in mind the materials, the conditions, and the methods of construction to be used. Sampling procedures need to be formulated, reformulated. The review of guidelines and specifications for preparation of specimens, for carrying out quality control tests need to be reviewed, and the whole idea of a healthy disrespect. That is, if the existing methods don't work or they are not likely to work, they are not likely to be applicable to your conditions of construction, be free to change them. Of course, I can understand that it is not possible for a person who's coming out of college straight away saying that this method is not applicable, that method is not applicable, and therefore there is a certain amount of experience which is required in order to be able to suggest that we will not use established method and rather use a new method, because we feel that that is the more applicable method. That is something which is more relevant for a particular application. But it should always be done, and as far as young people are concerned, they should always have their mind open that okay, this is not acceptable, this is not the best thing, possibly it needs to be changed, and you need to work to implement that change, and that change will come gradually. Please remember that even though I'm repeating some of these slides, the whole idea is that the sample should represent the real concrete. Now, once again, I'm drawing your attention to the regular standard testing of concrete, the way it is shown here. Now, this is how we stop. or this is where we stop. We proportion the concrete through the laboratory tests, come to the site lab and finalize a proportion. Now, in the lab, the mixing is done more often than not by a 100-liter mixer. You know how it is done. You try to think of the laboratories which you have been in and see what kind of or what scale at which they work. And from the projects that I have shown you in this discussion, whether it was shotcrete, whether it was underwater concrete, whether it was the pavement quality concrete placement, the scale is completely different. And that scale part is taken care of to some extent by ensuring that the lab tests are appropriately repeatable and modifications are made through the site lab where possibly the mixing of concrete, for example, is in an RMC plant. So once the first batch or the first proportions or the first cut of proportions is made available through laboratory tests, then it goes to the RMC plant. So that's the way it should be. Then it goes to the RMC plants from where the concrete should be manufactured, tested and found to be okay and used. Having said that, that may not be enough unless we do what is called a mock-up construction. Now that is something which is coming out today, that mock-up construction is the key for carrying out special constructions. If we are not sure how the things will work in a large construction project, never be shy of doing a mock-up construction. A construction which is larger in scale to specimens. So a specimen to me and my image is a 15 by 15 centimeter cube or a small beam, but those are specimens. Those are much smaller in scale. When it comes to a mock-up construction, it is not to real scale. Of course, you cannot do it to real scale, but something slightly bigger than specimens. Of course, it will be much smaller than the real construction, but it will give you an opportunity to actually test some of the technology which is used. Again, doing mock-up construction is an expensive affair. Mock-up construction per se will take some money, but that's a small amount of money compared to the total cost of the project. Just imagine that if we are able to do a mock-up, the idea will also be while you're doing the mock-up that the mixed proportions can be revised. Can we revise the mixed proportions if there is something that happens in the mock-up and it turns out that the water should be reduced, or water should be increased, cement should be increased, cement should be reduced, some admixture should be adjusted, whatever it is. In the curing discussion which we had, we said that in certain cases the water needs to be heated or the water needs to be cooled, or not only the water, but there was talk of some aggregates being heated or cooled. Now, if this is to be done, then to do this kind of an exercise, carry out the proportion in the lab is quite different from trying to do it at an RMC plant and then ensuring a temperature of fresh concrete. So these are the kind of things that you have to do in a mock-up construction, where you try to find out that you do all these things at a slightly larger scale and then try to make sure that the proportions that have been determined are in order. Here the sampling and the quality control for strength is all closer, much closer to the actual construction site. And then only we go for real construction. So this whole idea of a mock-up which comes out from a special concretes or a special construction procedure requirement is something which we need to be very, very open to and be willing to invest the kind of resources, because that will be always a good experience and help us do a good quality job as far as real construction is concerned. I want to show you an example of how our strength sampling or sampling for strength needs to be modified in order to do the strength for a shotcrete. Here is a panel which could be used for sample shotcreting. So you try to deposit concrete on this panel which has been placed at a certain angle. Now this angle can be different and needs to be standardized. If you want to insist that this panel should be overhead, go ahead and do that. You have to figure out what is the standard. If you want to do it, lay it out in your specifications. The contractor should know that this is how the sampling will be carried out. It will not be carried out using cubes. It will be carried out through a panel like this, from which cores will be taken, as we will see shortly. But then we need to standardize the size, including the thickness of the deposit, the number of layers for the deposit, angle and distance from the deposit, curing regime for the panel, and so on. So there are all these parameters which need to be decided when it comes to laying or creating this panel, which will be used to generate samples from the shotcreted concrete for strength. So this panel perhaps more truly represents the concrete which is placed in a tunnel lining like this, and we try to say that okay, the concrete in a particular portion here or a particular portion here or a particular portion somewhere here still meets the requirements. If you want to have reinforcement in this panel, go ahead and do the reinforcement bit as well, but that has to be part of the standards. The layers, when we were looking at some of the photographs, you would have noticed that this thickness of shotcreting in different applications could be different, and it's not necessary that the entire thickness is deposited in one pass. It's deposited in several passes at times. Now, what should be the methodology adopted to create this panel when it comes to reflecting the number of passes? So that's where engineering judgment will come in, that okay, these are more important factors and should be incorporated in the development of a standard for creating panels. These are less important factors and let's not bother about them. Then once the panel is made, we can always take cores from these panels, and these cores can be tested for strength and acceptance. This procedure for creating the panel, taking the core and having a certain process for acceptance and certain levels of strength for acceptance, this has to be laid down and made clear in your construction methodology and the specifications for a particular shotcreting project. These pictures here show exactly that. Creation of panels in order for whatever purpose. It could be for, in fact, testing of nozzlemen. Now, what is a nozzleman? The nozzleman or the nozzle person is one who's handling the nozzle of the shotcrete. Now, this is a very, very skilled job. It's not easy to be able to hold this nozzle and make sure that you are able to deposit this concrete here in an appropriate manner. This is as skillful, a very different kind of skill. Those of you who are familiar with welding, you would know that. Welding also involves a very skillful operation where the welder needs to know how to have the electrode being fed into the job and at the same time moving it. And even in welding, the material is deposited in several passes at times. So there are these kind of parallels that you can draw and have testing programs for nozzle men or nozzle persons. These are the kind of panels that can be created to check whether the quality of concrete being used or to be used, if it was a planning stage in the project, is acceptable, not acceptable, and so on and so forth. So these kind of panels, these kind of methods can be part of a mock-up. You take the whole process to a mock-up. A mock-up obviously involves a reasonable amount of concrete. In a lab, you can make do with about 100 liters of concrete. I'm leaving it to you to do a simple arithmetic that if we use a 100-liter mixer, how many cubes can we cast? Or the other way around, in order to cast, let's say, 9 cubes or 20 cubes or whatever it is, how much concrete do we need? But when it comes to a mock-up, it's a much larger exercise, and 100-liter mixers from the lab will possibly not suffice. And therefore, RMC plants have to be mobilized. So the entire team from different parts gets mobilized, creates the mock-up, and is better prepared to do the real operation. Similarly, if you're trying to do underwater concreting, as far as testing fresh concrete is concerned, that also needs to be tested in water. That is, we have a slump cone in water, must have a water tank, put your slump cone inside, do the slump in water, whether it is slump or slump flow. Most of the time in this kind of a situation, you'll probably need slump flow kind of workability. So the initial shape will be something like this. Remember how much is the diameter here? I'm leaving it to you. That diameter will deform into something and the final shape will be something like this. So this deformation of concrete from this shape to this shape should happen not in air but in water. So this testing for fresh concrete for underwater placement needs to be carried out underwater. So there's no point carrying out a slump test and getting the flow values, the initial value and the final value, and values like the T500 or whatever it is in air, because the concrete will be in water, and water will offer a different kind of environment by way of resistance to movement of concrete and so on. Issue will be what should be the depth at which this tank is placed. The issue can always be things like how deep should the tank be. Those are the kind of details which need to be left to the sites. The standards can try to specify it, and I would encourage you to try and read some of the literature and find out whether such standards have been developed. I'm sure there are there. Okay. Similarly for their strength. Recall that when we are doing a Treme construction, there is a Treme somewhere like this, and there is concrete here. So this concrete is being deposited using a Treme, and all this is water. So we are interested to find out what is the strength of this concrete, and this concrete was placed not in air but in water. So therefore, much like the test for fresh concrete, the cubes also need to be taken underwater, demolded and allowed to remain there. Of course, for the purpose of determination of strength, they'll probably have to be taken out and the strength determined. So that is where a small balance between the practice and the reality, a balance between the theory or the ideal situation and the reality can be done. That we cannot possibly test the concrete underwater. We'll take it out momentarily or for a very small period of time and test it in air, but at least the sampling and the curing happens in water, the sampling particularly. Now with this, we almost come to an end of our discussion today. I must let you know, share with you that some of the materials, especially photographs used in this lecture, have been communicated to me for only academic use, and the material should not be used for any other purpose without express consent. Something to think about. Concrete volumes involved in some large projects in the world. Once you see that, okay, if a large project involves, let's say, 100,000 cubic meters of concrete, and through your mixed proportions, mock-up exercises and so on and so forth, you are able to change or save 1 kg of cement. Just imagine 1 kg of cement is per cubic meter. Now this 1 kg per cubic meter cement in a 100,000 cubic meter concrete operation saves you 100,000 kgs of cement, and that is not a small saving. That saving itself will almost cover the cost of your mock-up and any other additional investment that you do in the planning stage. So try to think about these mock-ups and the initial planning, investment in that initial planning, and the resources you need and use during the initial planning from that point of view. Proportions of concrete used in some of the landmark projects in the world, to get an idea of how much cement was used, what was the aggregate, what was the kind of cost involved, and details about preliminary studies including mock-up carried out as part of the preparation for some special projects in the world. There are, I'm sure, and I know,
several studies, several case studies which are available in literature, and that's the beauty of the internet. That's the beauty of online discussion, that you have all the information available to you at fingertips. Try to get that information, relevant information, from the point of view of mock-ups, actual constructions, and I'm sure you'll be able to see the wisdom that is being sought to be communicated to you through the discussion today. I must once again thank my friends, students, and my colleagues for helping me understand concrete, and I look forward to seeing you in another lecture next week. Thank you.